This 7th grade science class has been conducting a year-long study of the water quality of a nearby stream. In this activity, they prepare for their research by calibrating their probes.
So really what we're saying is we need to calibrate this. We need to transform these numbers that come into volts initially, and we need to transform them into something that we can use, all right, as something that's readable and that makes sense for us, okay? How do we calibrate? How do you think we might calibrate pH? We've done this with temperature, but now how would we do it with pH? Do you have an idea?
Go to eCalibrate.
All right, we go to eCalibrate, exactly. We go into the eCalibrate program. Then what else do we do? Esther?
Go to Setup.
We go to Setup, okay, or else we're going to set up for our new Calibrate program. But what else?
Like when it gives you a reading of volts or something, and you take a substance that you already know the pH of.
Okay, that's what I'm getting at. I get a substance that I know the
pH of.
Do I only use one?
No, you use two.
Why do I want to use two? Why isn't one enough?
To set a range.
To set a range. Excellent. Okay, so Robert, continue. I'm going to use the substance. Thank you.
Then it'll give you a reading of volts, and you have to set like this many volts equals to like the pH of this. Like, say you know the pH is like 11 or something, and it gives you a reading of volts. You'd have to set it so like this many volts equals to 11 for pH.
Okay, exactly. And that's just from one end. So maybe I've set my basic end, and what about the other?
So then you're going to get like in a very acidic, substance, like a very extreme substance, for the to set a range, as Bram said. So then you're going to take this and put the pH in the computer, and then by doing that, the computer will find a formula that calculates from the pH, from volts to the pH,
Okay.
and that way you'll have the known standard.
Okay, then I have a known standard. And as we had seen a video before, they had to do that for thermometers too, right? We have to standardize equipment all the time. So when scientists pick up equipment, they don't just, plug it in and start working with it. When you get a computer, you have to set it up, right? Same thing with these instruments. These instruments have to be told what it is you want to measure. And there's a way to get that to happen. We had several learning activities today. The main one centered around water quality at the stream. And the importance there that means a lot to us is that we take the students to the stream so that they can experience science outside the classroom walls. And that's what the technology has allowed us to do there. And so we can assess water quality data by the students not only collecting the water quality data but observing it and everything that influences that data right there and experiencing it firsthand.
The students carefully calibrate their equipment before making further preparations. They then discuss photographs of the stream to look for physical changes in the environment.
One more thing that we're going to do today, okay, is we are going to work with the pictures that we took with our video, with our digital cameras yesterday, okay, or 2 days ago. And we came back, we downloaded them onto my computer. We put them in my file folder for you to share under Miss Gleason folder, and you have access to them on your computers. Okay? And they're named, and you have somewhere from 6 to 8 pictures of your stream. Okay? What were you supposed to do when you took pictures at the stream? What was your directive? What are some of the things that you wanted to capture? Emily?
Maybe like an overhead view so you can see the turbidity in it, like the amount of thin particles in the surface and so on.
Okay, so what are the things we kept in mind? We wanted to take pictures because we knew when we go out to the stream today, we want to take, all right, readings, okay, for what tests? Right? Just yell them out. pH, okay. Temperature.
Conductivity.
DO.
And turbidity.
DO and turbidity. Okay. Well, do the leaves dissolve, or what do we know leaves do?
Leaves like rot.
Right, they rot, they decompose.
Like dissolved particles that go into.
Yes, right, but after decomposition, right. So the only thing that might happen with these leaves are what? If we crunch them up, what might they do? They might add to our turbidity readings, right? Okay, but you know, not necessarily the conductivity, right? Because they're still solids. They have to decompose, right, in order for them to affect other things.
After analyzing their photographs and calibrating their equipment, the students are ready to visit the stream.
This is cool. We need hours out here, not just 45 minutes.
I know. I could sit out here for hours. Such a gorgeous day.
It's a wonderful day. Wonderful day.
This is like a million times better than sitting in a classroom.
Why is it better
Watching
than
some
sitting
over-
in a classroom? It's so warm.
Yeah, I get to be out in the sun and see things. Actually,
Yeah. You're actually
Yeah.
seeing things.
I don't
in front.
have to stare at an overhead projector on the stream. I can actually.
Yeah, there's a dead crayfish
That's
right
They're
there.
actually right here.
Yeah.
There's a crayfish.
What's this?
Oh, it's dead.
Oh.
Oh, a dead crayfish.
Well, that's not good.
I saw one shoot out down to there.
Yeah.
Some alive ones.
Okay, well, you have a lot to write down for observation. So let's see if the data suggests that this would support life that we're finding here, huh?
Yeah.
What did you have in the winter?
4,000.
No, 1,400.
1,400, okay.
I think it's a significant.
Okay, what do you need to check first? What do you want to check?
Have like that down, lever down as far as you can. So I would check it median calibration
Okay.
over 2,000,
There,
and then
Okay.
you want to check if you have it on the conductivity calibration.
sure. She had it on the wrong setting, so now let's see what she has. What's the ballpark?
570.
Ah, that sounds better. Much better. Okay, so about 500 something now? Terrific.
My predictions are coming true though too.
Are they coming
So I
true?
predicted it would be like more a little constant, but it would be a little bit more neutral. Like especially like those like farther down because of like fertilizer from lawns and stuff. So
Because of fertilizer from the lawns. So now you're expecting fertilizer from the lawns to be in here. So what is that going to do to your conductivity?
it's gonna make it a lot higher.
Okay, let's see what we have, all right?
All right.
Okay.
Can you get the water out of?
Is there anything as far as new pictures go that you'd want to take today? Or is everything just about the same?
It's just about the same like books wise.
Okay, great. So are you done with pH?
Yeah.
Okay, so why don't we get the probe back in there?
13.99.
Don't let the thing.
Don't let the.
Oh yeah, and Rashawn, you might want to tip in.
I can't see though.
Don't fall over.
Okay, 609.65.
The class returns to their classroom to analyze the data they collected.
And how about Adam and Anna? What was yours?
It was around 580.
About 580. Okay. All right, that's just a quick eyeball. Take a look at that. Okay? So think about that a little bit. We're starting off at about 1,500. What do we know about the water in the first section? Alice, what can you tell us about your section?
It's really deep.
It's deep, and what else?
It has a lot of conductivity. It's
Right.
the bottom of a hill.
But if we look at it physically, you go out to your section, you say, that's a deep bunch of water. And what else do you notice about
It's
it?
slightly murky.
Slightly murky. And what about movement?
Oh, none at all.
No movement. Okay? All right. Okay, so in section 1, I'm going to just kind of do this. And that's about section 2 a little bit. Okay, as we go through that. Let's go. It's still water, deep, and murky. Okay?
Students are required to identify relationships between different factors by creating a model using Model Builder software.
Well, now what I want to do is I want to just see you work with something very specific, and that's a longitudinal study of either pH over the seasons or conductivity. Okay? Now think about what that means for a while. Okay? Think about what impacts any one of those tests. think about what they impact, okay? Think about the environment's interaction with this. Think about what you have observed over the seasons throughout the year, from the fall, from the winter to the spring, when you were out there collecting that data. That's the real powerful thing here, is that you were able to go out there and collect that data and observe it, okay? So think about those things and see how is it that you would create a model, a small model, okay, on Model Builder that would demonstrate your understanding of that. Okay, so wait a minute. It's not appearing. What was your relationship here?
This, if the pH is medium or so, the quality is excellent. If it gets high, it's bad. If it gets low, it's bad.
Okay. Now, when you are building a model, you're trying to show relationship between objects and factors. Okay? So is that a relationship between the two of them? One affects the other as pH goes up. How is it written? Let's go back to the graph. Go back to your build. Okay, let me see your graph. Okay, so stream pH affects stream quality. Okay, so as stream pH increases, stream quality.
I don't see.
Stream quality increases?
Up until a certain point.
Okay, so based on that, okay, is that really going to work there? Up to a certain point. Go to bell-shaped curve. Water quality is a bell-shaped curve. Increases up to a certain point. So what do you want to show this bell-shaped curve? Is that what it's showing? Are you able to do that? Is that what it's allowing you to do? Why don't you put pH to a different color and see if maybe it's your yellow that's not working? Is that possible?
Only one of them works at a time.
Put like stream quality under green instead of
right. Yeah, get rid of yellow.
Yeah, then none.
Right. Now let's see if it works.
Wait, hold on.
It's back here.
Oh, okay.
But there's still no.
And still no. Okay, so is that all right? So one way to test out what would we do? What would we do to test out if it's a relationship that's not going to work like we want it to? What else can we do to test out that it's not just a malfunction in the program, that it might be the relationship we're trying to show?
I don't know.
What do you think you would do? Okay, we want to see, is it this relationship or is it every relationship, right? So how could we test that out?
Add another one.
Yeah, build a different one, right? Build a different relationship and see. Okay? And then you may have your answer. And you also may think about this a little bit more, all right? Because this is a real tough one with the pH, right? All right, because we do know that as it gets up to 7, to the highest point, that it would be neutral and that would be great for it, right? But I'm not sure if the bell-shaped curve can show that or not, right? So let's go ahead and try and build another relationship using another object and factors, okay? Think about things that affect the pH, okay? Other things that can happen that affect the pH. Then we might have our answer. I don't know if it's the program or not.